Welcome to our channel. Watch the video until the end. Leave a like, and subscribe to the channel to support us.
Once, it was thought that Jupiter was flat and resembled an M&M candy. This idea, as imaginative as it is unfounded because Jupiter, like the other gas giants in our solar system, has never had a flat shape. During their formation, such planets may start as disks of matter, but not as flat pancakes.
Jupiter is one of the oldest bodies in our solar system, with an age of about 4.6 billion years, similar to that of our Sun.
Jupiter's formation likely began through a process called disk instability. This process starts with the formation of a star, which does not appear as a round object, but rather as a vast disk of matter. During this phase, extremely hot winds of charged particles sweep through the disk. The dust in this disk, containing elements like carbon and iron, begins to clump together, forming increasingly larger objects. The presence of gas in the disk facilitates the aggregation of these solid pieces. Some may break apart, but others persist and form the cores for future planets. Even gas giants like Jupiter began from tiny dust particles. Gas giants form in the colder parts of the disk, where molecules move more slowly, making their aggregation easier. In these regions, water can freeze, and small ice pieces clump together with the dust. These dirty snowballs accumulate mass to form the cores of massive planets like Jupiter, Saturn, Uranus, and Neptune. In the warmer sectors near the star, rocky planets such as Mercury, Venus, Earth, and Mars begin to form. After the formation of the ice giants, there wasn't much gas left for the smaller planets, and tens of millions of years may have been required for them to form completely.
Even our Sun was growing, absorbing nearby gas and pushing away the gas that was farther away.
Interestingly, some planets like Venus and Uranus rotate in the opposite direction to the others, due to collisions with objects like comets and asteroids in their early days. There are also so-called tidally locked planets, which always show the same face to their star. These planets form when they are very close to their star, and extreme gravitational forces slow their rotation until it syncs with their orbital period. We have discovered more than 5,000 planets outside our solar system, called exoplanets, with sometimes very strange orbits. Some of these planets could not have formed in their current positions. Rather, they underwent a process of planetary migration. During gas-driven migration, for example, spiral patterns created in the disk can move a planet closer to or farther from the center.
Larger planets can also influence the orbits of smaller ones through their gravity.
There are also rogue planets, huge celestial bodies that float in space without a star. These can be as big as Earth or even Jupiter and could potentially harbor conditions favorable to life, such as dense atmospheres or moons with liquid water. In 2012, astronomers discovered an ancient solar system with a star about 13 billion years old, showing that planets can form under extreme conditions and with few heavy metals. This helps to better understand the variety of planetary systems and their evolution over time. Planetary migration is a fascinating phenomenon that explains how planets born in one part of the protoplanetary disk can find their way into completely different orbits, sometimes much closer to or further from their parent star. This phenomenon has been observed in many extrasolar systems, where the so-called hot Jupiters, gas giants in tight orbits around their stars, are often much closer than Mercury is to our Sun. It is believed that these planets formed farther from their star and migrated inward due to gravitational interactions with the gas and dust disk or through interactions with other planets. Another intriguing category is that of rogue planets. Not bound to any star, these solitary celestial bodies can traverse the galaxy. Some of these planets may have been ejected from their original planetary systems due to dynamic instabilities or close encounters with other planets or stars. These encounters can be violent enough to fling a planet out of its solar system, dooming it to wander in the darkness of interstellar space. However, despite their solitude, these rogue planets can still have interesting features, such as thick atmospheres that trap heat or moon systems that could theoretically support forms of life. The exploration of exoplanets has also revealed the diversity of planetary orbits. Some of these planets have highly eccentric orbits, similar to those of comets in our solar system, or incredibly long orbits, taking thousands of years to complete a round around their star. These discoveries challenge our understanding of the processes of planetary formation and suggest that the dynamics of extrasolar systems may be much more complicated than predicted by traditional models. Finally, the fossil solar system discovered in 2012 offers a unique glimpse into the early days of the universe. The central star, poor in metals and incredibly ancient, surrounded by two gas giants, presents an enigma for astronomers. This system contradicts the current understanding that planets generally form from gas disks containing a significant amount of heavy metals. Its existence suggests that there may be many more planets in metal-poor systems than previously thought, further expanding our horizon in the search for the variety and distribution of planetary systems in the universe. Through the study of these phenomena, astronomers continue to expand our understanding of the universe, revealing the complexity and beauty of the cosmic dance that governs the birth and evolution of planets. Each new discovery opens a window onto possible scenarios of planetary formation and evolution, bringing us closer to answering some of the deepest questions about the nature of our universe and the possibility of life beyond Earth.